So this is USB, what is it? USB tinkering for hackers and makers. My name is Dominic and slides change. My name is Dominic Spill. I work for an open source software and hardware company, and we are mostly interested in building packet sniffers, things like that, Bluetooth devices. If anyone's heard of the Ubertooth, then that's us. Sorry. And this is HackRF1, which is software-defined radio that we released on Kickstarter last year and finally delivered a year later. So some people in the room may have this. I don't know anything about this. If you've got questions about this, don't ask me because I didn't work on the project, and I'm not very good at radio. So we're working on a project called Daisho. I can't read the slides. Right, we have a bunch of projects for Bluetooth sniffing and various other things. And a couple of years ago, we started a project called Daisho, which was started out as a USB 2 packet sniffer and man-in-the-middle device. And through a series of emails between myself and my boss, escalated into a large project with US government funding that's currently, like every other government-funded project, running 18 months behind. And but we wrote a USB 3 core for FPGAs in Verilog, and we've open sourced that. You can grab that from the Daisho project now if you are kind of at that end of the USB tinkering, and it's pretty performance compliant. In fact, we sent bug reports to the people who make USB 3 compliance device test equipment because they failed to find. They thought we were failing tests that we were really passing, so we're more compliant than the compliance applications. So that's for USB 3, but I always wanted to attack USB 2 and things like that on a much cheaper level. And as you can tell, I'm at EMF camp, so I'm not going to come to you with a $2,000 piece of hardware or something. I'm mostly using cheaper hardware. And we were looking at this from a security standpoint, but this is, I'm also talking about it from a building interesting devices standpoint. I should also note that I have cobbled together these slides, and I can't entirely remember what order they come in, so I'm very sorry. And one more thing that I really like to pimp every time I talk is I've written a tiny little piece of code called fcc.io. It's a website. It's called fcc.io, and if you're ever interested, and this group may be, in looking up internal photos of devices and things like that have FCC IDs on the back, if you go to fcc.io/the FCC ID, it will bring up all of the internal photos and test documents and things like that. And you've always been able to search them on the FCC website, but it's almost impossible to find. If you go to the GitHub, there's also an archive downloading script, which the FCC don't particularly like me for, but you give it an FCC ID and it will just suck down everything, all the documents. If you give it an FCC vendor ID, I believe currently it will suck down all of the documents for that vendor and hammer the FCC's website. So go nuts.
So what time do you want to sort of do this job?
Yeah, about 10 minutes. 10 minutes. So I'm on camera. I've got no blame. I should also note the FCC, while awkward to work with, recently I've been working with Ofcom on some radio stuff, and Ofcom are an absolutely lovely group of people. And they are incredibly supportive of open source software and hardware, and they allowed me to come in and screw around with Bluetooth and DAB in their office under, I'm sure, some sort of license. But today I'm talking about USB, and specifically, can I have a show of hands? Everyone knows what a USB device is, don't they? If you don't know what a USB device is, this talk might be slightly over your head. So in 2008, they were selling at 2 billion devices a year. I'm pretty sure it's higher than that now. I've brought several thousand in the past couple of weeks doing this project. When I say most common device interface, I can't think of anything else that is more common on consumer hardware as an interface to plug in, except maybe mains power. Almost anything, any device you buy that you want to communicate between a host and device or something like that, mobile phones, anything like that has USB because it's become the standard, a standard interface. The U in USB, universal, is pretty accurate. And it comes in a couple of flavors. All right. Yes, 3.5mm headphone jack is possibly more common, but it is not quite as useful for data transfer of, say, files, or makes a pretty poor webcam, that sort of thing. Yeah. So I want to see, yeah, see 5 gigabit data transfer over 3.5mm audio jack at the next EMF camp, please. It comes in various different speed flavors. There's low speed, full speed, high speed, super speed, and super speed, I think is the new one. What's it called? Super speed plus, that's it. And super speed is USB 3. Low and full are USB 1 and 1.1. And then USB 2, which is pretty much what everything supports these days, is 480 megabits a second. And that's what I'm going to be dealing with. But it's backwards compatible with everything below it. And I'm going to try and give a little demo with a keyboard, which are almost always USB 1.1 devices. Here we go. So has anyone ever built a USB device, written firmware for something, played around with Arduino? Was one hand going up at the back? Few. OK, I may have pitched this wrong. So you have these descriptors which you can read from the device, and they tell the host operating system what kind of device it is. They give it an idea of which driver to use. They tell it there's a device class. So for example, a keyboard like this will act as a human interface device, and it will allow you to bypass certain driver requirements on things like Windows and a Mac. I have some other things that I've completely lost. Is there a USB mass storage stick over there that looks like a little man? Because it's the only one my code works with. I'm a professional. This is a USB Wi-Fi device, so that will turn up as a network interface. And yeah, it's a decapitated little man. That's right. Yeah. And USB mass storage devices. And that will appear as another device class. And so the kernel on Linux or any other operating system will know what to do with that device. The other thing they have is, in those descriptors, they have a series of IDs. So you can specifically identify this device comes from this manufacturer, and it is device XYZ. And the slide you can't see at the moment is about USB IDs, and it specifically says they're split into two parts. There's a vendor ID and a product ID. So the vendor ID is unique to the vendor. The product ID is unique to the product. In theory. And as makers and people who want to build our own devices and maybe build open source devices, we don't really have access to these because it's incredibly expensive to get a vendor ID and be assigned a block of product IDs. So thankfully, in recent years, OpenMoko went out of business, and which is a shame, I should say, because there are probably some fans of it in here. But they were kind enough to keep hold of their vendor ID block and start giving away product IDs for free. So if you go and look up on Google and find their wiki page about it, they have this large list of product IDs. And so if you were to plug in a HackRF right now, it would show up as being an OpenMoko device, because it's much cheaper for us to go and ask them very nicely if we can use one of their IDs, and they assign one to us, than it is for us to go to the USB implementers forum and pay them 40 grand to get a vendor ID. So I believe it's a subscription fee as well. So you have to keep paying them to maintain it. I don't know how they take it away from you, because you've already sold devices. But so if at some point you do decide to take some of my code and play around with things and build your own device, then as long as it's an open source project, OpenMoko will give you a free, give you one of their IDs, which just makes it easier when it comes to doing things like updating firmware. Because until they started doing this, we and every other open hardware developer was using vendor ID FFFF and just kind of using 1, 2, 3, 4, and so on for different revisions of their hardware. So you'd plug in an early Ubertooth, and you could update firmware on it for some completely different device, because we were overlapping USB IDs. So all the code signing and things we did for the firmware updates was completely pointless because it didn't stop you flashing the wrong thing to the wrong device. There's a picture coming up in a minute, which is kind of crucial, but we'll see what happens. USB proxy, right. So this is the crux of the talk. I wanted to be able to do interesting things with USB packets without having custom hardware. Travis Goodspeed and Sergey Bratis give out these little circuit boards called face dancers, and you have to be able to solder, and you have to wait the half hour it takes to do one USB transaction across the SPI bus that runs at a ridiculously slow rate. And so not only was it slow, and people have built fuzzers around it, it's got a nice Python interface and things, but not only was it slow, but there were a lot of people who didn't really want to build the hardware, and it was kind of out of reach of people. And I like the idea that you might be able to build an interesting device, without having to physically build the device. Because we all got into hardware in some way, and some of us got into it through electronics, and some of us got into it because the device we wanted didn't exist. And we said, well, what I really want is like this device connected to this device, but I've got to go and like design a PCB and learn how to do that and stuff like that, which is how the Ubuntu came about. And now we build this hardware. But it would be nice to be able to just hook a couple of devices up, write some code, and have it act as a USB device, at least a prototype. So what USB proxy does is it takes a piece of hardware, which I have here, called the BeagleBone Black. And you feel free to ask me afterwards why it's so much better than the Raspberry Pi. And we take a piece of code called USB proxy that we wrote that connects to the device USB port on there and connects to the host USB port and just passes the packets backwards and forwards between the two. And it's written in C++, and it relies on something in the Linux kernel called GadgetFS, which exposes a USB device to a file system, which thankfully no one in this room ever needs to care about again because we wrote USB proxy to wrap it, and it makes life a lot easier. It's quite hacky, and when we mailed the mailing list to tell them that we were using it, they said it wasn't necessarily a good idea. And there are comments in the code that are dated, say, like 2004, saying, oh, must remember to come back and fix this, and stuff like that. So it's probably going away at some point, but it's incredibly useful and flexible for what we need. So we're relying on that. And then to talk to the host side, we just use libUSB. And so it simplifies all the code, because I've just got these two fairly straightforward APIs, and I pass packets backwards and forwards between them. Something like this. I'm going to jump up on the stage and point to this slide. I'm sorry. No, I'll just wave. So this box that you can't see here says device. Basically, we have a device on one side, USB proxy in the middle, and a host on the other side. And we just have this relay in the middle that sends stuff between proxies on either side. And can anyone read this from the back? Excellent. Up here it says injector, and it says filter here. And essentially what we can do is we can hook in filters to screw around with the USB packets as they go across the device. And the injector does a very similar thing, but instead of just fiddling with the packets that are there, it allows us to inject packets into the stream. There are some complexities to do with the fact that USB devices, how was it phrased? USB devices are like Victorian school children in that they only speak when they're spoken to. You cannot just send data from a USB device to a host. You can with SuperSpeed because it's got a separate pair in the cable for each direction. But most of them, the host has to ask for the data. But we get around that with message queues and things like that. Again, nothing you should ever have to worry about because we've written USB proxy. I'll use the BeagleBone Black, which I've already said. It's because it has on-the-go hardware built in, so it has a device port on one side, it has a host port on the other, and we can just get it to proxy the traffic backwards and forwards. The reason I do this on the BeagleBone Black is because it's £35, something like that. And at the time that I started this, it was really easy to get hold of. It's not so much anymore. And we're investigating alternatives such as the Olimex Lime board, which is a little ARM board that does similar stuff. And I'm specifically trying to keep it to open source hardware because that's kind of my thing. So this is me going to attempt to demo USB proxy doing something. And for this, if anyone in the front row wants to be a willing volunteer, they are welcome to be. But don't all rush up at once. Yeah, that's fine. It's going to take me a minute to read the screen and work out where my mouse is and such like. Okay. I also have to remember, because it's been a little while, I can't read my own command. I'm sorry. All right. Let's see. That doesn't say segfault, does it? All right. Let's attempt. No. All right. That's not really what I wanted to do. If everyone could just keep chanting the word professional, I may begin to believe it. Where the hell is it? All right. And you. All right. Would you like to try typing something on the keyboard and seeing if you can vaguely see it come up on the screen? Excellent. So you can see the cursor moving. Now, did you actually type anything?
I typed something on the keyboard.
And you know what you typed, right?
Yes.
Is that what you typed?
Not even close.
Exactly. Yes. Anyway, so as my glamorous assistant has already identified, and if I could possibly find my cursor to switch back between tabs, come on, let the sun go in for just a minute. Ready? Can someone see it? All right, if everyone could just... There it is, got it, thank you. So, all right, what you can see is on the screen, I hope it's not rude. Okay, what you can see on the screen is obviously the thing that came through from the USB proxy, but if you see on here, I see what you did there. All right, something on the keyboard. So what happened there is I took the big one black, I plugged a keyboard into one side, I plugged it into my PC on the other. I'm just controlling it over SSH, but you don't really need the network connection. Not that any of you can see this unless I hold it up, but we then proxied the keyboard traffic, and as it was going through, I used a filter to dump the keystrokes to screen here on the BeagleBone, and then pass through a ROT13 version. And so what I was able to do is just with like 20 lines of code, I was able to screw around with the packets going across. I should mention there's absolutely no error checking in there. So if I were to now plug in like a USB mass storage device, it would attempt to ROT13 like the 12th byte of every data packet that went across, and everything would just fall over, and it would be confusing. But you're typing into the same window as the, yeah. But thank you for trying. I'm going to kill that now. OK, thank you very much. All right. What time is it? Sorry. Pardon? Excellent. I've got a little bit more time. So obviously, that's really useful, and everyone wants to ROT13 all the keyboard traffic and pay £35 for the privilege. But it's just an example of a very simple thing we can do in between. And I could switch back to my slides now. And, yeah, that's what I'll do. Where is my... Somewhere. Oh, great. Thanks, OpenOffice. All right, so I said I was playing around with mass storage devices. And mass storage devices are on USB, are essentially SCSI devices that get wrapped in a very simple protocol. And so again, with a couple of filters, I'm able to play around with the way they work. And I'm not sure I've got time to go into huge amounts of depth about this, but essentially, The SCSI transaction is a 3-stage transaction. The host sends a command saying what it wants to do, whether it's read, write, something like that. And then the data is transferred in the middle, depending on which direction the data should be going in for read or write or whatever. And then at the end, the device sends a status message back. And some people were talking about the fact that, I don't know if anyone works in the security industry and is on Twitter, but if you are, you'll know the term bad BIOS, which was the idea that there was this piece of malware that was propagating itself using all sorts of different methods. But one was that it was writing itself to USB mass storage devices as soon as they were plugged in, potentially without even the operating system's knowledge. So they were doing it at the control level. And we started thinking about how could you examine these writes and what's going on. And you can go and buy a USB protocol analyzer. There's a company called TotalFace that make one called the Beagle 5000. It's 5,000 because it runs at super speed. It's also 5,000 because it's about that. That's how much it costs. It is an excellent piece of kit. And I would absolutely recommend anyone else who can get US government funding to go out and buy one. But other than that, it's a bit out of everyone's price range, well, out of my price range, and the people I think in this room, most of them. So how do we analyze those writes and how do we look at what's going on? So I wrote some filters that did interesting things with USB mass storage writes. Now I should say, A, this is very experimental. B, I got these working at 6 o'clock in the morning before my talk at a conference recently, so they're very hacky. And C, for some reason, they only work with FAT16 file systems. So as long as your USB stick is as old as this USB stick that my girlfriend lent me, then it's fine. But I had a real panic when I lost this because none of my others worked. And until very recently, I didn't know it was FAT16 that was the problem. And the only reason I found out was because I reformatted this one, and it went to FAT32, and everything stopped working. And that was an incredibly big moment of panic. So this little guy plugs in, and what we can do, let me see how many more slides I've got on this stuff. Oh, this is the 3-stage, send a command, send data in one direction, send a status message. And this is what it looks like in Wireshark. It got into Wireshark because USB proxy will dump to Wireshark. Should have mentioned that earlier, sort of forgot. So if you want to analyze what your USB device is doing, you can dump PCAP files, and if you want to stream them over SSH, you can take them straight into Wireshark. And we're currently working with the Wireshark developers to allow non-Wi-Fi devices to capture directly, and USB proxy will be one of them, Ubtooth will be one of them, and GNU Radio for software-defined radio things will be one of them, as will Daisho. It's all our products because we're writing the code for them. And other people will obviously be able to add theirs, but the idea is that Wireshark's not just about Wi-Fi anymore, it's about anything that's packet-based and network traffic and things like that. So again, you can see the 3-stage write there. So let's say we want to block these writes. We want to stop this happening. We want to stop this malware propagating. But we want to be able to read our disks. So we could try a couple of things, and I've got to try and remember what they are, subtly reading my slides. So we can block the entire transaction, but that's going to tell the kernel on the host system is going to get confused because it's never going to get a status message. So we can just drop all the packets in the middle, but it never gets the status message. It thinks the driver's crashed, and it just resets the USB port. We can convert the write to a read. I've forgotten that one. We can switch it to the write to a read because the status messages are identical. Switch it to the write to a read, have them both send data to the man in the middle, and compare the data. And this is a really fun thing to do, except for going back to the thing about not being about speaking when they're spoken to. Something needs to elicit the read and the write from the read from the USB device, and due to the fact that I chose to write USB proxy in C++, I wasn't able to mangle that in. But I came up with a better solution, don't worry. The other option was read a block and just write exactly the same block back. And that's kind of where the code is at. And hopefully the demo is going to work, and you'll see how that works. But generally, the kernel, before it wants to write a block, it's very rare that your host system, you plug in a USB stick, and it comes up and it lists all the files. So it's read the file table, assuming we're all using FAT16, which we should be. it's read the file allocation table, and that data has gone across the bus. That means I've got that data on my USB device. The host is not going to try and write a block of data. It writes in 512-byte blocks, because that should be enough for anybody. And it's not going to try and write to a block if it doesn't know what's there. The only time it's going to try and do that is when it's formatting a drive, in which case my code will fail, or if it knows the drive is completely empty and it's trying to write to a completely empty block. But if I ever see a write that I've not previously seen a read for, then I know it's writing to empty blocks, so I know there's no data there. So that's not really a problem either. So what I've done is I've written a piece of code that, as the reads come through, it caches them on the BeagleBone Black. And then, as the writes come in, it compares them against the reads. It prints a diff out onto the screen to show you exactly what's changed. And then it drops the write, and it spoofs a status message back using one of those injectors. So what we're able to do is make the host think that the host read the USB disk without any problems, make the host write to the USB disk, believe the write happened, and then we're also able to analyze exactly the diff that was written. And hopefully this will work. Right. I need to remember what the command is. So give me just a minute. That didn't work. I clicked somewhere. All right. I will try. Can anyone see my mouse pointer? Somebody must be able to see it.
Left to left. Middle screen.
Oh, yeah, thank you. I've got it, I've got it. OK. All right. Now, it scrolled past really, really quickly. So, but what you'll see is it's reading, because it says the word read, and then a large hex digit, hex number here, and that's the block number that it's reading. Now, I should clarify something. What I'm doing here is I'm caching those in RAM on the BeagleBone. For anyone familiar with the BeagleBone Black, it has 512 megs of RAM. So not only does my code only work with FAT16 file systems, it only works with FAT16 file systems that have less than 512 megs of data in them. It is incredibly hacked together, but if anyone in the room would like to modify it and fix it and make it work, you'd be more than welcome. So hopefully, again, if I could find my mouse. Yeah, so there it is. Hopefully, we should see a 1 gig volume here that has no data in it because nothing crashed. And what I should be able to do now is I should, really hopefully, be able to write a file to it, unplug the USB device, plug it back into my laptop, and you see the file never happened, the file write never happened, and we'll get a diff. And at that point, I will consider it a successful demo, and we can all go home happy. All right, empty file, EMF camp. OK. Now, what the hell happened there? Right, so what I should also note is the diff only looks good if you use my font size. But hopefully, there should be somewhere up here, somewhere, there should be a section that is colored. Excellent. Right. And what you can vaguely see, if you can see the blue on the background on the dark projector, here there's a red section and there is a blue section. And the red section is where is the old data from the read, and the blue section is the new data. And you can see that I wrote oh, no, not if I stand in front of the projector, you can't. The sun is not on my side. You may be able to see right here. It's not going to make much difference on this screen. OK, all right. Yeah, I can't find my cursor now. All right. Oh, I'm going the wrong way. Going the wrong way. Wait. Let's keep scrolling, keep scrolling. Is it there? Can anyone see the word EMF camp in there? Yes. Yes, thank you. Yes. So, we have written a file called EMF camp. Now, the next part of the is ejecting the and finding my cursor again. There it is. Eject the drive. Pull the drive out. And everybody cross your fingers. Anytime it wants to pop up and tell me. Do I have a 1 gig drive there? Bear with me. So for the next EMF camp, it would be really nice if we did it in winter or inside. All right, there it is, there it is. I'm just going to bring it onto my monitor so that if the file is there, I can delete it subtly. No, the file isn't there. There's a completely empty USB drive, which is obviously what I knew would happen. Thank you very much. I know some of that was pity applause, but I will skip through my slides. I've got no idea what's going on. So you want to get involved in USB proxy. This slide's really old because I've written half this stuff already, but that's even better because now it's much more advanced. You can get involved in other ways. USB 3, if we had USB 3 host and device hardware, say Daisho, made by Great Scott Gadgets, then you might be able to build something on top of that to do this even faster, although we're going to do a lot of that on FPGAs and things like that, but there will be other hardware. I'd like to modify this to work on other hardware. I have made it into shared library and it does pass config files. I'd like some language bindings. It'd be really nice to be able to use all the code people have written for FaceDancer with USB proxy. And I'm sure there are people in the room who've written Python language bindings before. So if you have, I'd really like to talk to you about the best way to do that. And come and see me at the end. That would be great. FaceDancer compatibility because, you know, screw Travis. Thanks to some people. Am I running over time or am I? Brilliant, because there's a whole section of work I've done since I wrote these slides that actually might be interesting. So I should thank Azam Stasiak, and this one of the great things about working on open source projects is I push my code to GitHub, and he happened to notice it and get in touch, and we've been working together on this project for coming up for a year now, and I've never met him, but we did send each other Christmas cards this year, which is kind of cool. Was that an aw? Travis Goodspeed and Sergey Bratis because they're really nice about the fact that I say mean things about FaceDancer all the time. Michael Osman because he's my boss. I also met him on the internet and now I work for him, and he paid me to do this sort of stuff when I should have been doing things that make us money, and I've completely forgotten who David Formby is. Oh, David Formby from Georgia Tech, who was working on USB mass storage stuff at the same time as I was, and we collaborated on trying to work out why the hell we both only had one USB stick that worked. And in the end, we managed to discover that it was FAT16, and we're both very happy. And he's using USB proxy to do nasty things with industrial control systems. So there's that. I have another demo that works, but it's just not going to work with this setup, so I'll happily demonstrate it to people offline in a minute. But basically, what I was trying to explain at the beginning and have completely failed to do so is what I wanted to build was a Wi-Fi card that worked across multiple operating systems. I know this doesn't reference any of the rest of my talk, but I wanted to build a Wi-Fi card that works across multiple operating systems. And I know Linux has pretty good Wi-Fi card support for doing raw packet, raw frame injection and things like that. So I picked up a little Atheros card. Oh. I picked up a little Atheros card, USB card, and I can plug it into any Linux system, and I can run Kismet, or I can run Wireshark, and I can look at analyze traffic. But I can't do that on, say, my Android phone, or a tablet, or a Windows box. And you would not believe how much of the traffic in the Kismet IRC channel is, why doesn't Kismet work on Windows? And various things. So we decided, rather than telling people to go away quite often on IRC, we would write some software to solve the problem. And so Mike Kershaw and I have been working on using USB proxy and a library called LawCon, which is Loss of Radio Connectivity Library, that abstracts away the differences between Wi-Fi chipsets to create a generic Wi-Fi device based on the Big Bone Black and any USB hardware that you can plug into it, and present one generic interface to Windows and OS X and Android. And so as of later this year, we should have Kismet and Wireshark both running on Android with generic devices, and the only thing you need is a 35-pound piece of hardware to adapt it. So hopefully, and that demo always segfaults. So I will happily do that later. If someone finds me in the bar, I will happily try and show people how that works and explain. And I would really love for people to be interested in getting involved. And if you think outside the box of, I'd really love to be able to hook device X up to device Y, or do this interesting thing in the middle, or I'd love to be able to write a really generic USB device using some GPIO pins, which the Big Bone Black has loads of, then come and talk to me, because it's really, really simple now, and you can do it. You don't have to worry about writing firmware. You don't have to worry about making hardware. All of that stuff is just abstracted away from you, and I'd love for people to start using it. And that's it. I will open it up for questions. Maybe. Questions, there you
go. Yeah, it looks really good. I was just wondering, if you just wanted to just log data, what kind of throughput can you get with it?
I get asked that question every time I give a talk about USB proxy, and I've never tested it. Okay. And the reason I've never tested it is I'm not sure I'm going to like the results. But I would guess my stock answer is a lot faster than face dancer, a lot slower than professional hardware. I would say we're never going to get anywhere near line speed, so we're not going to get 480 megabits. But I would say that actually the big limit on this is I've only got 100 megabit Ethernet to dump the packets off. Right. So you might be able to get a couple of seconds at close to 480 megabits, but you're going to fill up the RAM on the BeagleBone before you get there and things like that. So I should test it, I'm aware, but I haven't yet.
So would the target device just slow down, or would it tend to just drop packets and then...
I would guess it would slow down. That's a really interesting question. So there's a slightly strange thing with the way, because we're terminating both the USB connection, we're actually turning one USB connection into two. So it won't time out even if you've got large latency, because we've already acted the packet from the other side. So we've got two separate connections, and we're just proxying traffic in between. So there's some interesting, we get around a lot of problems that other people have with this. For example, Face Dancer has to stall the connection every now and again and say, I'm still working on it, and stall the host. Whereas we don't have to do that, because the host has already got its answer, and then we just go back to it and say, actually, we've got more data for you, and things like that. So we could probably slow down the transaction in the middle if we were logging, because we'll just add latency into there. We'll add delay on the movement of the packet. So we'll probably just slow down the connection. But some devices would probably fall over if you tried to slow down their connection.
Cool. Cheers.
USB mass storage doesn't care. It just goes at whatever speed you let it run at. I know, because my code got into infinite loops and it didn't crash. But any other questions? Excellent. Oh, there is one up the back.
There's another approach to debugging USB connections also using Wireshark, but using a VM to capture the data. How does this compare?
This is a lot more complicated than using a VM to capture data, but isn't that why it's fun? In reality, yes, using a VM is a great example, but it's obviously a lot simpler, and you don't have to buy hardware and things like that. But my counter example would be if you, for example, look at, I've completely forgotten his name now, but the guy who reverse engineered the protocol for the Xbox Kinect. The only device he could connect it to was an Xbox. You can't run an Xbox in a VM and look at that traffic in between. So you need a hardware device to sit on the line in the middle. So it's things like that. Also, USB and virtual machines are absolutely a nightmare in many cases. So things happen differently in the VM using USB from the VM than they would elsewhere, because it goes through two USB stacks and it gets really confusing. And we know from trying to support people using our hardware in a VM under Windows, for example, that actually things just go wrong that you can't necessarily predict. So I think it's less reliable. Having said that, this was written by me, so it's not got a high degree of reliability right now. Again, please submit bug reports and patches and just take the project off my hands. Would be great. Any other questions? Anyone want to volunteer to just write code for me, please? Excellent. All right, thank you very much.